A spurious correlation is a correlation that doesn't have an actual association. Spurious correlations will become more common with the increased use of big data, and they are more likely to occur with time series data that have similar trends. Okay, now interpreting R using the explained variation. The value of R squared is the proportion of the variation in Y that is explained by the linear relationship between X and Y. So let's take a look at example number 1, an explained variation. Okay, using the 9 pairs of data in the table below, we get a linear correlation coefficient of R which is equal to 0.947. What proportion of the variation in numbers of tickets sold can be explained by the variation in jackpot amounts? Well, let's just go back and figure out how do we get this R anyway. If we put our values into StatCrunch, the first table represents the jackpot, therefore those are all the numbers there, and then the tickets. So let's go to Stat, go to Summary Stats, and then we're going to scroll all the way down to where it says Correlation. And then we're going to select both of those columns. And then we're going to select compute. And therefore it gives us the following value, 0.947. And this represents the linear correlation R. So now in order to find the explained variation, we take the value of R that we find and then we square it. So if we take R, which is 0.947 and then square that value, then it gives us 0.896809000. We're going to round this to 3 decimal places to get 0.897. This represents the explained variation. Now, we want to represent this as a percentage, so that means that we want to multiply this by 100%. And if we multiply this by 100%, then we're going to get 89.7%, which represents the explained variation. So here's the interpretation. We conclude that 0.897, or approximately, if we round this to 90% of the variation in numbers of tickets, can be explained by the linear relationship between jackpot amounts and numbers of tickets sold. If we take 100% and subtract 90%, which would give us 10%, this implies that about 10% of the variation in numbers of tickets sold cannot be explained by the linear correlation between the two variables. And last, just to end the section here, interpreting R with causation. Don't go there. It says correlation does not imply causality. We noted previously that there is sufficient evidence to support the claim of a linear correlation between lottery jackpot amounts and numbers of tickets sold. We should not make any conclusions that includes a statement about a cause-effect relationship between the two variables. We should not conclude that an increase in the jackpot amount will cause ticket sales to increase. Common errors involving correlation. Number 1, assume that correlation implies causality. Number 2, using data based on averages, and number 3, ignoring the possibility of a non-linear relationship.